And the last thing we'll do related to differential equations that might help you prepare for the AP exam is finding solutions to a differential equation. In college, depending on your major, you might take an entire course just called differential equations. If you end up getting a math PhD, you'll probably take like 3 different courses that are all focused on differential equations. So just this topic in general has a lot of depth to it. So, and you'll learn a lot of different methods and all that. Of course, this course is just an intro to differential equations and everything calculus related. So we're just going to learn one method known as separation of variables. And the method is exactly what it says. Like, you're going to separate the y's to one side and the x's to the other side. And then we can just use integration to get our answer. So let's say we wanted to solve this differential equation. We're trying to find some general solution for what the y would be that makes this equation true. We want to get the y's to one side and the x's to the other. Well, all the terms of the x are always already on this side. So I just want to divide both sides by 3y plus 2. Oops, that's a 2. And that's going to be y prime over 3y plus 2 equals x squared minus 4. And now that I have them separated, what I can basically just do is integrate both sides. And here's where it might be helpful to think about the y prime. Remember, the derivative is the same as dy dx. So if I think about this as dy dx over 3y plus 2 is x squared minus 4, I can multiply both sides by the dx. And then integrate. And I'm basically just saying this to show you that you really don't have to care about the y prime part when you're doing these problems. So now I realize I'm finding the integral of 1 over 3y plus 2 and the integral of x squared minus 4. So that right side, the more straightforward one, because that's going to be x cubed over 3 minus 4x. And again, whenever you do an integral with x, you get a plus c. On the left-hand side, we have 1 over 3y plus 2. 1 over that's going to be the natural log of 3y plus 2. And I have to do a correction. You could do this being use substitution, but I just know I'm going to have to multiply this by 1/3, because when I take the derivative of the 3y plus 2, I'd have to multiply by the derivative of the inside, which would be 3. I need to cancel out with the 1/3 because there's no 3 in that left-hand side. So that's the solution, basically. But the basic idea for most of these is that you want to get to a point where you have y by itself, because you want the answer is y equals this. So the first thing I do is multiply everything by 3. And here's the thing I think gives students the most trouble for this is dealing with that c. C is just some generic constant. I can make it basically whatever I want. So if I can make c whatever I want, 3c could be whatever I want. So instead of writing 3c, I can just write c again. Now I have the natural log is equal to all this. So if I raise both sides to the e power, the e and the natural log cancel. I'm going to get 3y plus 2 equals e. All right, then I have to subtract 2, divide by 3. To get my final answer. So if I make y that, again, I could pick anything for c and I'd get the correct solution. All right, so that is my final answer. All right, there's some things you can do with simplifying the c, but I don't want to kind of harp on that for too much in these videos. All right, just give you a basic idea what's happening. But the way we solve these equations, separate the x and the y, take integrals, and then try to solve for y. One extra thing you might have to do is to solve an initial value problem. That just means you're actually going to have to figure out what the c is. The first part's still going to be the same. I'm still going to divide both sides to separate the x and y. Again, sometimes you'll have to change how you separate x and y, but that's going to be the same. And now I take the integral of both sides. Oops. And I just realized the integral on the left uses a technique we haven't learned, so I'm just going to tell you what the answer is for the integral on the left. It ends up being the natural log of y minus 2 minus the natural log of y plus 2. All right, that's something you would learn in Calc BC. I just didn't realize that I chose a problem that needed that. And then on the left-hand side, we're going to get x squared plus 3x plus c. And again, we're going to solve for y, which is going to take a little bit of effort. All right, but we can combine these two using our rules of logs. It's a 2. Raise both sides to the e power. Then we can multiply both sides by y plus 2. So I'm going to just for writing purposes, I'm going to call this all, let's call it capital A for right now. So it's going to be y times capital A plus 2 times capital A. I want to get the y's together, so I'm going to have y minus y times capital A equals 2 capital A plus 2. And then factor and divide, I'm going to finally get y equals 2 capital A plus 2 over 1 minus capital A. So if I rewrite that as my final answer, I'm going to get 2 e to the x squared plus 3x plus c plus 2 over 1 minus all of that. All right, so that is our answer that we want, our general solution. And then to find the exact solution, we would plug in 0 and 1 and see what c is. So we want all this to equal 1. X is going to be 0. So we're going to get, let's see if I can write it over here. I want y to be 1. We plug in x equals 0. And now we just want to solve this for c. Let's see, so we'd multiply both sides by 1 minus e to the c. Probably want to get the e to the c's on the same side, so we're going to get negative 1 equals 2 e to the c plus e to the c. Combine those into 3, so it's going to be negative 1/3 equals e to the c. And take the natural log of both sides. All right, again, a lot of work, and we had to use a technique that you haven't even learned yet to take the integral of that. So I wouldn't worry about this problem too much, just showing that, sometimes you do have to figure out what c is at the end, in order to find the exact solution. So now I put in the natural log of negative 1/3 into all there and get that exact solution. Now we'll do one last example to make up for that last one, which is way more complicated and have to be, again, separation of variables. I want to get the y's on one side, so I'm going to turn this into y prime over y squared equals 1 over 2x. I'm basically dividing both sides by 2x and y squared. All right, that way, now that I have the y's and x's separate, I can integrate both sides. The integral of 1 over y squared is going to be negative 1 over y. The integral of 1 over 2x is going to be 1/2 natural log of x. Just using plus c. All right, and to solve for y, I can multiply both sides by y. And divide by all the stuff I don't want. This is going to be negative 1 over 1/2 natural log of x plus c equals y. All right, so again, it's just like integrating. It's a little bit more integration practice, where there's just kind of one extra step at the end of solving for y. All right, so I separate the x and y from each other, take integrals, and then solve that resulting equation for y. Again, in practice, there's some kind of creative things you can do with the c part, because c is basically any number, whatever you want it to be. So if you multiply or divide with c, you can just turn it into another c, which is kind of an interesting thing. But in general, you can just keep the c there and solve for y. All right, so there's some web assigned practice titled Differential Equations. You can work on this. Again, these videos are just kind of the starting point for differential equations. It should be enough for you to get through the practice problems and for what you would actually need on the AP exam. All right, the big things that you can actually definitely memorize or know that will help you on the AP exam are what is a slope field and what is a solution to a differential equation. All right, I can't imagine there's going to be more than one question about actually solving a differential equation. All right, but those first two things are definitely accessible, and I think all of you can do and accomplish. All right, but go ahead and try those web assigned problems about differential equations and see how you do.